Hello and welcome back to Introduction to Robotics. This is Lecture 2, Part 4, and in this part of Lecture 2 we're going to talk about pulse width modulation, which is the way we control the velocity of motors, the rotation speed, and a couple of different configurations of external switches that can be used to turn the motors on and off in conjunction with your Arduino software. So let's get started. So first let's just talk about pulse width modulation. Pulse width modulation is the modern way to provide speed control on DC motors. Basically, the idea is that rather than providing a voltage that is proportional to the velocity that you want the motor to turn at, what you do is provide the power that is some percentage of the full power available from the power source. So, for example, if we turn the power source on 100% of the time, then we get 100% power. If we turn the power source on no percent of the time, then we don't get any power. Those make perfect sense. And if we turn on the power half the time, then we get 50% power. So the way we do this is we provide switching. So specifically in the case of the Arduino, we turn on and turn off the enable line to the H-bridge at a frequency that's so high that the motor can't respond instantly to it, but rather uses the average power sent to it to drive its windings and make it turn. So as shown in this slide, which is actually from the Arduino web page, you can see that if we have a 0% duty cycle, then there's no voltage going to the motor driver. And at the bottom, if we're driving at 100%, then we're providing 5 volts, or in our case actually about 6.3 volts all the time. And the intermediate 25, 50, and 75% duty cycles show a varying amount of on-time to period ratios that result in these 25% on, 50% on, and 75% on power to the motors. Now note also that the specific Arduino function called analog write is also shown there. So we actually do an analog write of a value to a particular pin, the PWM pin, and by so doing set the duty cycle. So PWM, or pulse width modulation, has really come on as the preferred way to drive smaller DC motors and servos. There are other ways. In the old days it was done with linear circuits, and if we were using other kinds of motors, we could be using what is called variable speed drive. But for everything that we're going to do in this course, and for everything that you'll run into in the typical hobbyist or low-end robotics activities, the motors are going to be DC motors, and you're going to use PWM to control their speed. Okay, so the period is the frequency at which this PWM process is being cycled, And generally on most systems it runs from 1 kilohertz up to 10 kilohertz. There are lots of commercial systems that do PWM at 10 kilohertz. In the case of the Arduino, however, the PWM is at about 490 hertz, which is entirely adequate to keep the motor running at a smooth rate. But as you can see, it's a little bit lower than you might run into on other systems. The duty cycle, as I previously said, is the ratio of on time to period and can run from 0 to 100%. The reason this all works is that the motor acts as a low-pass filter. So actually, in fact, the signal that's going to the motor is being turned on and turned off 490 times per second. But the motor, being an inductor and having this field created because of the current running through its windings, has some inertia, electrical inertia, and as a result it takes a little bit of time for it to drain down from having the field created. And at the rate of one cycle every 2 milliseconds, that is around 500 hertz, that field just can't respond at that rate. And as a result, the motor just keeps turning. And that's good because that allows us to do speed control with this much simpler interface. The PWM approach really came out of the digital electronics because it's very easy to turn things on and off, and we can effectively get this varying power setting by using the switching. In a previous, that is part 3, we talked about H-bridges, and the H-bridge facilitates this PWM approach because it uses the line in for direction and the enable pin as the PWM input to the motor driver. And so those transistors have no trouble switching at 490 hertz. And so we get this on-off behavior being transmitted through the H-bridge and therefore providing the power to the motors. And you may want to go back and look at the data sheet on slide 15 to see how that H-bridge is provided with the inputs from the Arduino. Okay. Now, another thing that is useful and important actually in this first lab that you're working on is the use of contact switches to turn on and turn off your motor. Okay, so on this slide are a couple of drawings of different representations of wiring of these contact switches. And the one on the left is for a pull-down configuration, and the one on the right is for a pull-up configuration. And you might note explicitly that on the left-hand side, that circuit includes an external resistor. These come from examples in the Arduino reference. So how do these two circuits look if we look at the schematics? Well, on top is the pull-down circuit, and what you see there is you have your voltage source plus V, you have a switch, and the V-sense, which is actually the wire going to the input, the digital input, in our case pin 2, and below that a resistor, and that resistor tied to ground. So the logic for pull down goes like this. If the switch is open, then the potential that's on V-sense is the same as ground. No current is flowing, and so there's no voltage drop across the resistor. Thus, we have a 0 voltage reading. We could say it's off. We could say it's false. And in Arduino speak, we would refer to it as low. If that switch were closed, however, then current's going to flow from the voltage source to ground, past V-sense and through the resistor. In that case, you can see that the voltage drop will occur across the resistor, and therefore V-sense would measure a plus V, or typically a 5-volt voltage signal. And in that case, we would say the value was 1, or on, or true, and in Arduino speak, high. If we look at the lower schematic, we have a pull-up wiring, and in that case, the V-sense is tied on the upper side of the switch, and so when the switch is open, the potential at V-sense is the same as the potential at plus V. Again, no current flowing, and therefore, if we ask what the value is there, it's going to be plus V, or 1, or on, or true, and in Arduino speak, high. So all of those things mean the same thing. In contrast, when that switch closes, you can see that the potential for V-sense will then be drawn down to ground potential, and in that circumstance, it's at ground, it's 0, it's off, it's false, or low. So what's the difference? Well, in the case of the pull down, it's logical, in quotes, meaning that if you think about it, the switch is open, and when we ask what the switch condition is, we get back a low or off. And that makes sense. When it's closed, we ask it, we're going to get back on or high and true, and all of those things kind of match our intuition about how the switch ought to read. In contrast, the pull up configuration, when we ask it what the value is with the switch open, it comes back as on or high or true, and only when the switch is closed do we get off or low. Okay, so what that means is if you're using that switch and you wired it for a pull down, then you don't have to think about the logic. It's as you would expect. In the pull up, however, you have to invert the logic. That is, when you read high, you think open or off, and then when you read low, you think contact switch closed, on, and in the case of lab 3, the bumpers are actually in contact. The other difference, and it does make some difference in how things get built up, is that the pull-up resistor is internal to the system. It's part of the Arduino board. And so by configuring it to be pull-up, that's all you have to do. Whereas in the pull-down, you physically have to wire a resistor into the circuit with the switch, in series with the switch. And so in some cases that may be not quite so convenient. So as long as you understand the difference between those two and how they work, you'll be good to go, and you can choose to do either one. There are some details about how to do the pull-up configuration, and I'll leave it to you to find that in the Arduino reference. That's all from now. See you in the next lecture.